In DTF printing, powder behavior can sometimes be confusing. Uneven distribution is one of the most common situations. But the real question is not what we see. It is how we understand it. Powder does not stick evenly. Some areas look heavier. Some areas look lighter. It may appear stronger near edges or lighter in flat areas. Sometimes the difference is very stubble. Sometimes it becomes clear visible. Even within the same print, the variation can be obvious. So the question is, what does this really mean? When this happens, the reaction is usually direct. Something must be wrong. Maybe the powder is unstable. Maybe the film is inconsistent. Maybe the coating is uneven. So adjustments begin. People change powder, change film, change settings. But here is the problem. Even after changes, the result may still vary. So the question becomes, if the material is the same, why does the result change? DTF printing is not controlled by one factor. It behaves as a system. Ink defines the surface. Powder responds to that surface. Film provides the structure. These elements do not work independently. They interact at every step. If this interaction shifts even slightly, the result will also change. Powder does not simply fall. It responds to physical conditions. Electrostatic state affects how particles move. Surface condition affects how particles attach. Film structure affects stability. So distribution is not random. It is a response to the current system state. This leads to a key understanding. Powder does not choose where to stick. It follows conditions. Where attachment is possible, it stays. Where conditions differ, it behaves differently. So uneven distribution is not a defect. It is system behavior. So when powder is uneven, do not change everything immediately. A better approach is to observe step by step. First, look for patterns. Does it repeat in the same areas or change every time? Second, observe the surface. Is the ink behavior consistent? Third, consider environment. Has humidity changed? Has temperature shifted? Because in many cases, nothing is wrong. The system is simply responding to conditions. And what you see is not always the full boundary. The better question is not what is wrong, but what conditions are interacting here.